This is Dhyanesh Krishna. I'm doing my third year in Electronics and Communication Engineering in SN College of Engineering. So I and my three of my classmates participated in the Embedded System Internship conducted by Emertxe Technologies. And in this presentation, we'll be giving an overview about our internship and our journey with respect to our internship. So the contents that will be discussed are C programming by Dhyanesh Krishna, that's me, and embedded systems will be discussed by Gokula Krishnan. Tools used and PIC architecture interfacing will be discussed by Bharatram. Implementation of washing machine and demonstration of washing machine will be discussed by Joshua Daniel. C programming language. So C was created by Dennis Ritchie at the Bell Laboratories in 1972 as a system implementation language for the Unix operating system. It is a very popular language. Despite being old, is simple and flexible programming language that is widely used in various applications. Its characteristics include it's a general purpose language, is a free formatted language, it's highly efficient, and its portability to different operating systems and situations, and its library facilities. These characteristics distinguish C programming from other languages which came thereafter. So let's see about basic data types in C. It includes the basic distinguishes is integral value and a float point data type. So in integral data type, there are two specific data types, which is integer and character. Character is used to store single characters. It typically occupies 1 byte of memory. Integer data type is used to store integer values. It typically occupies 4 bytes of memory on most systems. Floating point. With respect to floating point, we have two data types, float and double. Float is used to store floating point numbers. It typically occupies 4 bytes and provides single precision floating point representation. Whereas double is used to store double precision floating point numbers with higher precision compared to float. It typically occupies 8 bytes of our memory. Okay, let's look at the modifiers and see. There are 5 types of modifiers, which include short, which stores 2 bytes of memory, which takes 2 bytes of memory. Long stores 4 or 8 bytes of memory. Long stores 8 or 16 bytes of memory. Signed stores both negative and positive numbers. Unsigned stores only positive numbers. With respect to signed, in case if it's a character, the entire memory allocation of characters are a 1 byte. In case of signed, it is split into both, and half is given to the negative and the other half is given to the positive. Conditional constructs in C. As the name implies, conditional constructs follow a block of code or implement a block of code with respect to the condition, whether it's true or false. So that we can broadly classify the conditional constructs with respect to the number of iterations they undergo. So they can be single iteration or they can be multi-iteration. With respect to single iteration, there are if statement, if else statement, if else if statement, nested if, and switch case. In if statement, will be given an condition, and if the condition is true, it executes the block of code inside if statement. Else, it just goes to the next line of the code. With respect to if else statement, there is a condition given for if. If that is satisfied, it executes this block of code under if. If not, it goes for the else statement, else block code, and it executes the else block and then comes out of the conditional construct. In if else if statement, there are two conditions. There is a condition with respect to if, and there is a condition with respect to else if. And with respect to nested if, there is an if condition inside an if condition. So when there are multiple conditions that are to be checked, and that too with respect to single condition, like for example, uh, if you want to check whether a person is both what to say, like if he's a voter, and then in turn we have to check whether this guy is above 40 or below 40, then we'll have an if condition at the beginning whether his age is greater than 18 or not, and then inside if condition again we'll have an if condition checking whether he's above 80 or less than 80. So that's with respect to nested if. And switch case, switch case is used when there are multiple if conditions like case in order to be executed. And with respect to switch case, we have a default case In case if none of the cases are satisfied, then it defaultly executes the default block code, and we have to use break statement at the end of every case present within the switch case in order to make sure that only a single case is executed and not all of the rest of the cases. And conditional constructs with multi-iteration includes for, while, do while. With respect to for, there's an initialization, there's a condition, and then increment or decrement. This increment or decrement can be given in either in the for loop bracket or inside the loop too. But the syntax should have two semicolons within the for loop brackets and while loop. And for loop is executed until the condition is false. Same with respect to while loop. There's inside a while loop we check for condition, we go for the execution of code until the condition is false. Whereas in while loop, the the incrementation or decrementation should be inside the loop. With respect to do while loop, first the code is executed once and it is checked for whether the condition is true. If the condition is true, it goes for the second iteration, third iteration until the condition is false. In do while 2, there is increment or decrement of an initialized variable is done inside the loop. So operators in C. Operators in C includes arithmetic operators, which includes addition, subtraction, division, multiplication, modulo operator. Modulo operator gives remainder, and division operator gives quotient. Relational operators include less than equal to, greater than equal to, and checking if they are equal, and checking if they are not equal. And logical operators like and, or, not also exist. Pre and post increment operators, these are widely used in for loops, while loops, in order to increment or decrement a variable. Pre and post increment. And bitwise operators includes and, or, left shift, right shift, etc. Assignment operators includes equal to. Plus equal to implies that you add an constant with respect to a variable. For example, I plus equal to r is nothing but I equals I plus r. And then same with respect to subtraction, multiplication, division, and modulo. Other operators include ternary operator, takes three operands or variables. It is a way to shorten the simple if-else code of the block. Yeah, which reduces the number of lines, thereby reducing our runtime, etc. Arrays in C. So an array is nothing but it's a user-derived data type. Array is a collection of data of same data type. It cannot have two different datas of two different data type. So first element will be with the lowest address and the last element with the highest address. Each element in the array is accessed by index, and with respect to array, they are, as you can see in the image, it is a contiguous memory allocation. Here we have stored an integer array. We have created an integer array, which means integer takes around 4 bytes of memory. So the second element is stored in the address, which is incremented by 4 bytes from the base address of the index first element. So we can see that for the first element takes base address, then plus 4 for the second one, then plus 8 for the uh, third one with respect to the first one. So this is contiguous memory allocation. Strings in C. String is a contiguous sequence of characters, set of things tied or threaded together on a tin cord. End of the string is marked with special character called the null character. This is useful when you try to iterate, and then uh, in order to know that you have reached the end of the string while iterating through it. This is useful. Memory will be allocated also for null. The difference between a character array and a string is that string is terminated with a unique character. Pointers in C. Pointers are used to store the address of a variable or a memory location, and the type of the pointer is the type of the variable that it's going to point. For example, if you want to point an integer variable, then your pointer should be of a type integer. We can access and manipulate the data stored in that memory location using pointers. As the pointers store the memory addresses, their size is independent of the type of data they are pointing to. We add an ampersand to the variable in order to store the address in a pointer. We add an asterisk star mark to pointer to extract the value of variable it is pointing to. As you can see, they have created a variable x and then an integer type pointer, since it's going to point x, which is an integer type, and we have initialized the x, and then we have stored the address of x in pointer. In case if we use dereferencing thing, we'll get the value of x. We can retrieve the value of x from pointer. Functions in C. A function is a set of instructions which are set to perform a specific task. Functions can be stored in a library and reused. When some specific code is to be used more than once at different places, function avoids repetition of the code, thereby reducing the number of lines and then also reducing the runtime and increasing the efficiency of the code. A function can have three parameters: input, operation, and output. For every function we call, there will be a stack that is created. After the function is executed, the stack will be destroyed. We have two methods of parameters passing. Pass by value. Changes made to the parameter inside the function has no effect to the actual argument. Then it's called as pass by value. With respect to pass by reference, changes made to the parameter affect the argument. So the rest will be, so the embedded systems will be continued by Gokul Krishnan.
Hello everyone, I am Gokul Krishnan from SSN College of Engineering. Now we see about what is embedded system and its types, and also see the component in embedded system. What is embedded system? Embedded system is the combination of computer hardware and software designed for a specific function or task. Embedded system may also function within a larger system. The system can be programmable or have a fixed functionality. Examples of embedded system used in industrial machines, consumer electronics, agricultural and processing, industrial devices, automobiles, digital watches, airplanes, vending machines and toys, as well as mobile devices are possible locations for an embedded system. Embedded system play a crucial role in aerospace and defense system also. They provide essential functionality such as real-time data processing, control and communication, ensuring the reliable operation and mission success in aviation system. Now we see about types of embedded system. Embedded system are classified based on two factors: performance and functional requirement. Performance of microcontroller. Based on performance and functional requirement, it is divided into four types: real-time embedded system, standalone embedded system, network embedded system, mobile embedded system. In real-time embedded system, real-time embedded system is strictly time specific, which means this embedded system provide output in a particular time interval. This type of embedded system provide quick response in critical situations, which give most priority to time based task performance and generation of output. Further, this real-time embedded system is classified into two types: soft real-time system and hard real-time system. Soft real-time system is not so strictly follow deadlines. If deadline of the one task is passed, still result or output is accepted. In hardware real-time system, deadline or time of task is strictly followed. Task must be completed in between time frame, otherwise result may not be accepted. Example: traffic control system, military usage devices, medical usage devices. Second, standalone embedded system. Standalone embedded systems are independent systems which can work by themselves. They don't depend on a host system. It take input in digital or analog form and provide a output. Example: MP3 player, microwave oven, calculator. Third, network embedded system. Network embedded system are connected to a network, which may be wired or wireless, to provide output to the attached devices. They communicate with embedded web server through network. Example: home security system, ATM machines, card swipe machines, like that. Fourth and last, Mobile embedded system. Mobile embedded system are small and easy to use and require less source. They are most preferable embedded system. In portability point of view, mobile embedded system are also a best. Example MP3 player, mobile phones, digital camera. And second, based on performance of microcontroller, it is divided into three types: small scale embedded system, medium scale embedded system, complex embedded system. In small scale embedded systems are designed using 8-bit or 16-bit microcontroller. They can be provided by a power by a battery. The processor uses very less or limited source of memory and processing speed. Mainly, this system does not act as an independent system. They act as any component of computer system, but they did not compute and dedicate for a specific task. In medium scale embedded system are designed using 16-bit or 32-bit microcontroller. This medium scale embedded system are faster than that of small scale embedded system. Integration of hardware and software is complex in this system. Third, complex embedded system. Now we are see about components of embedded system. Components of embedded system includes CPU, diagnostic port, ADC, DAC, sensor, actuator, human interfaces, memory, FPGA, like that. All of these components work together to enable the desired functionality of the embedded system. Processor. Any embedded system core component is the CPU. It determines how well the system works. There are three different processor types: 8-bit, 16-bit and 32-bit CPU. For embedded systems, smaller applications require fewer bits. Larger applications call for embedded system with larger bits. CPU consists of microcontroller or microprocessor or SoC, system on chip. ADC used as analog to digital converter, DAC used as digital to analog converter. Human interfaces is a component which is used to display the output to the user. Diagnostic port is used to check if everything is working fine or any need services. The microcontroller itself, it have two different type of memory. They are RAM and ROM. ROM is a code memory, whereas RAM is a volatile memory. RAM is read or write in infinite time. It is volatile memory. It requires power supply to retain the data, and if there is no power supply, the data will be erased. In ROM, write one time, read infinite time. It is a non-volatile memory, which means does not require power supply to retain the data. In ROM, there are two different type of memory: SROM and DROM. In ROM, there are three type of memory: PROM or OTP, EPROM or UVROM, and mask ROM. In SRAM, it need a constant power supply to retain the data. It is more cost and consume less power. In DRAM, constant power supply plus extra power supply also give to refresh the data. It is less cost compared to the SRAM and consume more power compared to SRAM. In PROM, OTP or PROM writes only once and read infinite time. OTP means on-time programmable memory. Example: micro oven, toy, mobiles also. In EPROM or UVROM, read infinite time but write n time. UV ray are used to erase the memory in UVROM. Mask memory. Mask memory is a read-only memory whose content are programmed by the integrated circuit manufacturer. The desired memory content are furnished by the customer to the device manufacturer, and the data stored below this memory will never get corrupted. Under the hybrid memory, there are two types: EEPROM and flash memory. EEPROM have is non-volatile memory, persistence, write 1 million time and read n time, n infinite time. It byte accessible. The size of space are 256 byte to 128 kilobyte. Under the flash memory, there are two types of flash memory: NOR flash memory and NAND flash memory. In NOR flash memory, it is byte accessible, it is non-volatile memory, read in infinite time and write in n time. Execute in place, not need to load code in RAM for execution. Used to store code in microcontroller. It is a very important function in NOR flash. In NAND flash memory, it is block accessible. It stores data in block 256 byte, 512 byte. It is non-volatile memory. Read infinite number of time and write for n time. Same as NOR flash memory. It is less reliable and it is used to store data in example SD card, pen drive, like that. These are all about the component in embedded system. Now we will see about advantage and disadvantage of embedded system. Advantage of embedded system include less power consumption, lower operational cost of system, also provide a high performance and efficiency in lower cost, and same hardware can be used in variety of applications. Disadvantages of embedded system: it take larger time to marketable because a single chip take so much time to implement or design the single chip. Developing a system require more time due to this functional complexity, and also have a high development effort to be put to design a embedded system. Now we will see about basics of PIC microcontroller. What is microcontroller? Microcontroller is an integrated circuit which is capable of being programmed to perform specific tasks. Unlike microprocessor, microcontroller has all component integrated in a single chip, and also it is cheaper than microprocessor. It is less flexible and require less design complexity. In this project, we are use PIC16F877A microcontroller. Now we will see about some specifications of PIC microcontroller. PIC stand for Peripheral Interface Microcontroller. It has 5 port A to port E. Port A have 6 pins, port B 8 pins, port C have 8 pins, port D have 8 pins, port E have 3 pins. It is very easy to use flash memory technology so that we can write or erase until 1000 times. It can also support SPI protocol, support serial communication for it has 2-pin transmitter and a receiver. It also support 3 timer, timer 0, timer 1, timer 2. Now we see about what are the software we can use to implement this project. PICSIMLAB and MPLAB X IDE, XE9 compiler used for compile purpose, and also PIC Genius PIC16F877A microcontroller board.
Hello everyone, my name is Bartram. I'm going to explain about the software components and PIC architecture used in this project. So the first software component which we are going to see is MPLAB X IDE. MPLAB is a development environment for the development of embedded applications on PIC controllers, and it is developed by Microchip technology. So MPLAB X is the latest version of MPLAB IDE. MPLAB X supports editing, debugging, and programming of microchip 8-bit, 16-bit, and 32-bit PIC controllers. So MPLAB XC8 is a C compiler for 8-bit PIC and AVR devices. So next software component which we are going to use is PICSIM simulator. PICSIM simulator is a real-time simulation tool for development of both integrated with MPLAB or AVR GDB debugger. Uh, PICSIMLAB supports PICSIM microcontrollers and some other SIM AVR microcontrollers. So PICSIM supports many interfaces which can be connected to the PICSIMLAB. So for LEDs can be connected and can be used for seeing the simple outputs, and Ethernet shield W5500 for internet connection, and color graphic display ILI 9340 with touchscreen can also be connected for complex applications. Now coming to PIC16F877 architecture, so it consists of two buses. One is data bus and address bus, which differentiates the address and the data lines. So PIC16F877A has 5 ports. Port A, which is 8 pins. Port B, uh, port A 6 pins. Port B 8 pins. Port C 8 pins. Port D 8 pins, and port E 3 pins. And the PIC16F877A support 3 timers: timer 0 with 8 bit, timer 1 with 16 bit, timer 2 with 8 bit. Then CPU is the main important aspect of any microcontroller. So in the CPU of PIC16F77A, it has ALU, a memory unit, and a control unit accumulator which performs arithmetic and logic operations. Mm, And the important aspect of embedded system is analog to digital converter. It has in this PIC16F88, it is controlled by ADC 0N0 and ADC 0N1, and it has 10 bit A to D converter as shown in the figure. So PIC16F77A has 3 types of memory. One is program flash for storing the program memory, which is 8 kilobytes, and data memory 368 bytes, and data EEPROM 26 bytes. Then we are going to see about the port B in PIC16F877A. So port B is a bidirectional port. Similarly, port D has similar function with port B. It is also a bidirectional input-output port. It's 8-bit wide. Port B as a data direction register TRIS B, and port D as similarly as a data direction register TRIS D, which is 8-bit wide. So the TRIS register is used for selecting the input or output for a particular port as shown in the figure. Then we are going to see about timers in the PIC16F877A. So the in timer 2, it has two 8-bit registers, that is TMR2 and PR2. TMR2 is used to store the initial count value, and PR2 is used to show is used to store the ending count value. Both the registers are readable and writable. Timer 2 has a prescaler and postscaler, which is used to make additional divisions in the frequency clock source. It is connected to internal clock or 4 MHz, and the interrupt is generated on a overflow. So next is we are going to see about the prescaler and the postscaler working. The prescaler divides the input frequencies to 1:1 or 1:4 or 1:16 scaling before it goes to the TMR2 register. So after it reaches TMR2 and PR2 register, it goes to post scaling, which divides the output frequency 1:1 to 1:16 frequency ranges. So the timer 2 control register, which controls the operation of timer 2. The first 2 bits 0 and 1 is timer 2, which controls the prescaler of the timer. So if 00 is input of first 2 bits, then its prescaler is 101 means prescaler is 4, 10 means prescaler 16, and 11 means prescaler 16. Then the second bit tcon2, which controls the on and off of the t2 con register. The 1 means timer 2 is on, 0 means timer 2 is off. The next is the last for 3 bits, the last 4 bits, which controls the output post scalar bits. So if 0 0 is input, 1 is to 1 post scalar, 0 0 0 1 1 is to post scalar, and so on. If all ones are given, 1 is to 16 post scale is done. So this is the explanation of timer to bits. Then a block diagram shows the working of the timer to register, shown in the figure. The oscillation frequency of a divided by 4 is given as input, and the prescaler is done before the timer to register, and it is going to the comparator. After comparing with the PR2 register, it is going to the post scalar. Then it is monitored by a TMR2 IF. IF means interrupt flag. If interrupt is generated, then the execution of the program changes, which I will be explaining in the next slide. So next topic is interrupts. Interrupt is a very important task done by microcontroller. So interrupt means an external or internal requests coming to the microcontroller to stop the processing of the program. So first the microcontroller acknowledges the request, then attends to a request and go back to processing where it was interrupted. So a PIC 16F 77 architecture consists of 20 internal interrupts and 3 external interrupt sources, which can be associated with different peripherals like ADC, universal synchronous uh, transmission, timers, and so on. Then interrupt handling is shown in this figure. When the interrupt is generated write instruction, it goes to the interrupt handler where it has a particular instructions to be executed to handle the interrupt. Then after completing the interrupt execution, it comes back to the next instruction where it is left. Then the classification of interrupts. Interrupts can be broadly classified into hardware and software interrupts. Uh, Software interrupt is basically due to OS, which is not usually found in microcontroller, but hardware interrupts are due to registers, timers, and switches present in the program. Then hardware interrupts can be divided into two types: maskable and non-maskable. In maskable interrupts, it can be disabled. The interrupts can be disabled. In non-maskable interrupts, the interrupt cannot be disabled. The maskable interrupts can be divided into external and internal interrupts. External interrupts come from the external devices, which is interfaced to the microcontroller. The internal interrupts come when the internal uh, internal problem occurs in the microcontroller. Now I'm going to explain about the LED interfacing with a PIC controller. So I'm arranging LED array 2 to port B and LED array 2 direction register to test B in the main.h file. In main.c file, I am giving the array.2 direction register as 00 as the initial output. It is given as output function. So I am in the main function. I am initializing the initial configuration function, and I am talking the LED FF, which will be all the LEDs will be off, and for 50,000 millisecond, and after 50,000 millisecond, all LED will be on as the input is given as 00. Let us verify this using the uh, uh, PICSIMLAB. Now I am loading the X file. So I am owning the port B. As you can see, the LED is blinking and LED is perfectly working.
Hello, my name is Joshua Daniel and I'll be explaining the problem statement, the system requirements, and the implementation part of the project. The problem statement. This project focuses on simulating a washing machine using a PIC simulation lab aiming to replicate real-world washing machine functionality in a virtual environment. The project begins with a comprehensive understanding of washing machine components, cycles, and operations. Parameters defining laundry status, such as fabric type, load size, water level, are identified. And the requirements, the microcontroller is the PIC microchip we are using, PIC 16716F. 16F. PIC 16AF 877A, and various switches are used as input for this microcontroller. That is, the switch 5 is used as power on switch to power on the washing machine. Switch 5 is used to power on the washing machine. Switch 6 is used to stop or pause the washing machine when executing. Switch 4 is used to navigate, is used as navigation to scroll between the options provided in the program. Switch 1 is accesses door status, that is, the switch 1 access door. And the output of the microcontroller are a display, an CLCD display to display various optional washing status options that can be used for this program, a buzzer, and a motor. The first requirement is the power on screen. When the when when the code is dumped and executed, when the code is executed, the power on screen is displayed. When the code is executed, the first screen which is displayed when the code is executed is the press switch. It's the power on screen. To start the to power on the washing machine, press switch 5 to power on the washing machine, and a powering on screen is displayed. And when pressed, a powering on screen is displayed. Next, the washing program screen is displayed. Washing program screen. The second requirement is the washing program screen. Washing program screen contains various washing program menus like daily, heavy, delicates, and 12. There are 12 programs listed here, which we have used in this program. To select a particular washing program. To select a particular washing program, long press for 10 seconds. Switch 4 for day. Next, when when a washing program is selected, water level menu is displayed. Water level screen is displayed. The water level screen contains water level menu. Contains the water level menu stated like auto, low, medium, high, and max. Describes this levels describe the level of water used. The user needs to select the water level. To select the water level, long press the key for long press switch 4 for 10 seconds. Long press switch 4 for 10 seconds. Start after the water level is selected. Start screen is displayed. Start stop screen display have two options: start the program or stop the program. If User have options to start or stop the program. If switch 5 is pressed, display the function selected and time. The function selected and time is displayed, and the screen is switched to function, and the screen is switched to function screen. If say switch 6 is pressed, go back to the washing program screen. The program goes back to the washing program screen. In the function screen, the next is function screen. Function screen displays the washing program. Function it performs. The program starts executing. The function screen is displayed. The program starts executing. The selected program starts executing. Timer shows for how many minutes or seconds the wash is going to take place. User have options to start or stop the ongoing program. Fan is on during the program. The last is the completion status screen. Completion status screen. Before that, switch 1 access door for washing machine. If door is open, the program starts and the door status is displayed. When the program completes, when the completion screen is displayed, when program is completed, program completion screen is displayed, and the buzzer gets on. Thank you. Now we will see the implementation part of the project. Here the code is already done. Let us select the code. Here RB4 is switch 5, RB3 is switch 4, RB4 is switch 5, and RB5 is switch 6. Now press key 5 to power on the washing machine. Let us press key 5. Now we can select, now we should select the washing programs as per our requirements. We can select our washing programs as per our requirements. Like to scroll through these options, we have to press switch 4. When switch 4 is pressed, the option gets incremented. To select a particular program, long press switch 4 for 10 seconds. After that, we can select the water level. You can also scroll through the options using the switch 4. Now if you have to select water level, again long press switch 4 for 10 seconds. Now we can either start or stop the program. If start is switch 5 is pressed, start option is pressed, the program gets executed. Now as you can see, the fan is on and the timer is decrementing. The timer is decrementing. Let us wait until the timer goes to 0, until the process ends. As you can see, the program is completed. You can remove the clothes.